So we were continuing our look at geometry foundations with an investigation of what will end up being probably one of our most important tools in geometry, and that is the distance formula. So I'm just going to say this right off the bat. Distance formula is important. We're going to use it a whole bunch. I'm going to encourage you to try to not memorize it, but rather just understand where it comes from. Because we get into trouble sometimes when we just try to, rote memorize something and then just apply it. And that's where, we end up putting a negative where we should put a positive, or flipping variables around, or whatever it may be. If we have a true understanding of where it comes from, we're going to be in a good position. So we're going to look at distance formula. We're going to take a look at just finding a distance between things that's a little simpler, and then we'll look at actually finding a distance between points that necessitates the use of the distance formula. So let's look at really a simple example. So let's imagine for a second that we're gonna talk about our Cartesian graphing system here. So let me go ahead and that was just poorly done. We're gonna draw in some axes here. So this will be my y-axis, this will be my x-axis, and so let's imagine for a second here that we pick a couple points. This one looks pretty good. That's going to be the point 1, 1, and then this is going to be the point over here that is 5, 1. And so we don't really need anything to help us find the distance between 2 points. It's easy enough that we can see that since these 2 points have the same y-coordinate, that really what I need to do is just count over, and what I'll end up finding is that I missed one. 1, 2, 3, 4, 5. Oh, well, no, I didn't miss one. Whatever. It's 4 units away. It's 4 units away. And we can do that just by counting, because we know, as when we define measurement, that if we're only moving in one direction, I can just find the difference between my 2 coordinates, so in this case 5 and 1, and it'll tell me that they're 4 units apart. And so this works specifically because these two points lie on a horizontal line. I can pick 2 other points over here and find the distance between them if they are vertically aligned. So if this is the point, let's say this is -4, 1, and this is the point, -4, 8. Well, I can do the same thing. Since these are vertically aligned, my x-coordinates don't come into play, and so my y-coordinates, I'll end up doing the same thing, where I just take the absolute value of 8 minus 1 and compute that to get that they're 7 units apart. So the question then, of course, becomes, well, what happens if we have 2 points that do not align horizontally or align vertically? So let's try this again. Let's pick 2 points that are good points. Let's start with 1, 1 again, because why not? This is the point 1, 1. And I have another point that's over here. Let's say it's the point 4, 5. So I go over 3 units, and then I go up 4 units from where I was to get to the point 4, 5. Well, here's my issue now. I don't know how to find the distance between these 2 points. They're not vertically aligned, they're not horizontally aligned, I can't just count over, and so I have to find this distance somehow. Well, whenever I have a problem that I don't know how to solve, what I typically do is that I would like to turn it into a problem that I do know how to solve. So I'm going to break it down into something that I do know how to work with. So we just said, hey, I know how to find horizontal and vertical distances. Let's go ahead and draw in the horizontal and vertical distances between these 2 points. So what happens here is that I get a segment here, I get a segment here, this is the change in x, and this is the change in y between these 2 points. So for my x values, this coordinate has an x value of 1. And this coordinate here, since it's dropped down vertically from my other point, has an x coordinate of 4. Over here, what I have is a y coordinate of 1. And right here, I have a y coordinate of 5. So how does this help me? Well, now I can find these horizontal and vertical components. I still know how to find the distance here, and that's fine, but I can find these horizontal and vertical components. So just like before, I can take this absolute value of 4 minus 1, which is 3. This is 3. And then over here, I have the absolute value of 5 minus 1, which is 4. Okay. So again, how does that help me? I found the horizontal component, I found the vertical component, that's all well and good. But what can I do with this? So I have to kind of think back to something that I've seen before. So when I draw on this horizontal and vertical components, what I actually form is a right angle between the two of them. And so what I have here is a right triangle. And we have to think back to the days where we learned this thing called the Pythagorean Theorem. The Pythagorean Theorem. Hope I spelled that right. Pythagorean Theorem, which tells me that whenever I have a right triangle, it'll always be the case that the two legs, if I square them and add them together, what I get is the hypotenuse of this right triangle squared. And so I can use that here, I can apply this here to my coordinates and say that, well, if I want to find the distance and I know what these two sides are, it'll be the case that, we'll call this D for distance, that 3 squared plus 4 squared will be equal to the distance squared. So 9 plus 16 will be equal to the distance squared. 25 will be equal to the distance squared, which means that the distance is just equal to 5. No big deal. So how can I take what I just did here and turn it into something that I can use every single time? So what I'm going to do is I'm going to come up with this formula that, again, we're going to attempt to not memorize, but something that I can use now. So just in general, if I have 2 points, and they can be wherever, let's say that those 2 points are here and here. What I can do is break these down into the x component and the y component. So how do I find these? Well, this is the point x1, comma, y1. And this is the point x2, comma, y2. So right here, this segment, which blue did I use? This segment here will be the difference between my two x coordinates. So the absolute value of x2 minus x1. Right here, the green will be the absolute value between, or the difference between y2 and y1. So using my distance formula, if this is the distance I really want to find, it'll be the case that if I square this distance right here, so the absolute value, let's get that back. The absolute value of the difference in my x's plus the absolute value of the difference in my y's squared will be equal to my distance squared. Now, absolute values, what it does is that it takes, the positive difference or, addition or whatever it is, it makes it positive. And so when I square something, that also makes things positive. So this is kind of redundant. I don't need to have the absolute value here. What I can say is just that this will be the equivalent to x2 minus x1 squared plus and then y2 minus y1 squared will be equal to my distance squared. And so I can just do one thing, move these around, and say that, well, the distance between my 2 points will just be equal to the square root of, and then the quantity of x2 minus x1 squared plus y2 minus y1 squared. All right, so big important takeaway here is that whenever I want to find a distance between 2 points, and they're not horizontally and vertically aligned, I can use the Pythagorean theorem to find that distance. The way that I do that is I find the horizontal component, which is the difference in my x's. I find the vertical component, which is the difference in my y's. If I square both of those, add them together, what I should get is distance squared. And so just solving for that distance then is just the square root of those two things. So this is my distance formula. Again, highly encouraged not to memorize, but if we understand where it comes from, I know that I'm just taking the difference between these two values, squaring them, taking the difference between these two values, squaring them, adding them together, and then that will be equal to my distance squared. So this is a distance formula. We're going to use it a whole bunch. Very important tool for geometry and moving forward.